Notice, and this is the typical copyright, we continue with mathematics syllabus for CSEC 2018 as of January 2026. This syllabus has not been revised, but there are plans to change the structure of this exam from 2028 and onwards, with a few pilot projects now being conducted in a few Caribbean countries. The syllabus itself remains unchanged. The main planned change to the CSEC level math exam is to split the exam into two parts. Current structure and format of the CSEC math exam. There is a paper 1, which lasts for 1 hour 30 minutes, and it consists of 60 multiple choice questions from all sections of the syllabus as outlined below. There is also a paper 2, 2 hours and 40 minutes, and this paper consists of 10 compulsory structure type questions from all sections of the syllabus. No choice, all sections will be tested, as I just said, with compulsory questions. If you are in school as a student, you would also do what is called School-Based Assessment, SBA, which is paper 031. Your teacher will give you certain instructions. You will come up with a project, conduct the project, get some data, and then carry out certain statistical analyses on that data to come up with some conclusions. That is if you are in school. If you are not in school and you are writing this exam as a private candidate, that will be paper 032 as opposed to 031 up here. And in this case, you will be given data and asked to conduct certain statistical analyses on that data to arrive at some conclusions. That's paper 3. There are 3 profiles: knowledge, comprehension, and reasoning. In paper 1, 18 marks, that is to say 18 questions, will be based on knowledge, 24 marks or 24 questions on comprehension, and 18 more marks or 18 questions based on reasoning, for a total of 60 marks, which will carry a weight of 30% if you get everything right. Paper 2, you could follow this reasoning: 30 marks on knowledge, 40 marks on comprehension, 30 marks on reasoning, for 100 marks, which would make up 50% of your final grade. And paper 3, which is the SBA or the alternative to the SBA, 20% more, or 20 or 40 marks. And then from a total of 200 marks, that will be scaled down to 100%, and your percentage will determine your final grade. Schedule of videos. Sections 1, 2, and 3. All 51 of these videos have been published on YouTube in their entirety. Please make good use of them. Section 4, 5 of these 17 videos have been published on YouTube in their entirety. Section 5, statistics, 5 of these 18 videos have been published on YouTube in their entirety. Section 6, algebra, 7 of those videos out of 22 have been published on YouTube in their entirety. Section 7, relations, functions, and graphs, 9 of these videos have been published on YouTube in their entirety. That is 9 out of 26. And we are now at section 8, geometry and trigonometry. This is the 21st of 26 videos from this section. After that, of course, we will have to do section 9, vectors and matrices, and this schedule may have to be pushed back a little. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Going back to section 1, number theory and computation, I have divided that into 33 videos, and they are all available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. If you plan to write this exam, this is a reminder that you need to know the times tables from 2 to 12, since calculators are not allowed in paper 1. Still on section 1, most of these videos are applicable in the primary schools, where students themselves could look at the video either before they get to class or after class for reinforcement on that topic. Teachers can use them in the inverted classroom, and some parents who don't feel comfortable teaching their children math could look at the videos with their child and then ask the child to explain it back to them using the same examples in the video. For example, if I expand that blue box there, you will notice video 6 says add, subtract, multiply, and divide whole numbers. That is work done in grade 3 in the primary school. Then video 7, add, subtract, multiply, and divide decimals. Work done in grade 4. Video 8, add and subtract fractions. Work done in grade 5. And then multiply and divide fractions, video 9. Work done in grades 5 and 6. And then you have order of operations, conversion of fractions to decimals and percents, and LCM and HCF, and so on. If you are looking at this video, you are already at the channel ROEL 922 on YouTube. If you rearrange it in playlists, the playlist we are talking about right now is this one down here, section 1. Most, if not all, of section 1 is work done or should be done in primary school. Do not be misled by the title, CSEC Mathematics Section 1, Number Theory and Computation. It is not as difficult as it sounds. Section 2, Consumer Arithmetic. All 12 videos from this section have been published on YouTube in their entirety. Section 3, Sets. All 6 of these videos have been published on YouTube in their entirety. Section 4, Measurement. Some of these have been published on YouTube in their entirety, the others partially. Please note that if you need full access to these videos that are only partially published on YouTube, see the directions in the description below. Section 5, Statistics. Again, same principle. Some of these have been published on YouTube in their entirety, and the others partially. Same principle applies here. Section 6, Algebra, which many students find difficult. 7 of these videos have been published on YouTube in their entirety. That's 7 out of 22. The others partially, but even those that are published partially, at least part of the objective has been covered. Section 7, Relations, Functions, and Graphs. Now, this is a fairly difficult section, and I have published 9 of these videos in their entirety on YouTube, 9 out of 26. The others are partially published. Again, if you need full access to these videos that are partially published, please see directions in the description below. Before we go on, recall I had said in the introductory video that you will need a good math textbook or maybe a set of 2, especially to get more practice questions. CSEC recommends these in its syllabus. From those, I would recommend these last 2 here, as seen in this slide, because they form a very good 2-volume set of math textbooks that is quite adequate for the current and future proposed changes in the structure of the CSEC math exam. This is a picture of volume 1, Mathematics, a Complete Course with CXC questions by Raymond Tulsi. And this is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, as of late 2024, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2 for now. You can navigate by topics or years, where all questions for the past several years have been worked out for you. If you still have a question that you need explained after that, you can ask the AI assistant either by text or voice, and most likely that will be explained for you. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. That is the URL for this website. On the next slide, I will show you what the home page for that website looks like. This is the home page. You will have to register first, and subsequent to that, sign in. This is that URL again. I will include that URL in the description of this video below, so you can easily click on it and be redirected to this website. Also, another reminder that this formula sheet you see here on the left is provided for CSEC math examination papers. It is included in a full copy of the syllabus. Just in case you don't have such a full copy, there will be a link in the description below from where this formula sheet can be downloaded. This is the top part of that formula sheet, so you could see it a little closer. I am stating the obvious here. You do not need to memorize these formulae, as this formula sheet will be provided during the examination. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. So we are at section 8, geometry and trigonometry. We have completed all these objectives from that print screen page. Objective 5, completed. Objective 6, completed. All of these objectives on this page have been completed, 7 to 11. So we are now here. This is the last page of this section with objectives, and this is video 21. To summarize what we have said so far, we have reached up to this point. Video 20 in this section, those have been published in their entirety, the others partially. Right now, we are here. Video 21, objective 8_12. When this is finished, it will be published in its entirety. As it relates to the rest of these videos, these other 2 will be published in their entirety, and the remaining 3 here partially. So we are here. And it says, use Pythagoras Theorem to solve problems. Objective 8_12. So this is the print screen from your syllabus. Says the same thing. Well, obviously, if we are going to use Pythagoras Theorem, we need to know what is Pythagoras Theorem. So we will talk about that first, and we will look at a few examples how to use it. Now, Pythagoras Theorem applies only to a right triangle. If you see a triangle like this with a right angle, it is called a right triangle. Now, the side opposite the right angle is called a hypotenuse. This side here, opposite the right angle. Consider this triangle here. The right angle is down here. The side opposite here is called the hypotenuse. It is important that we are able to identify the hypotenuse of a right triangle in order to understand and use Pythagoras Theorem. So this is what Pythagoras Theorem says. the square of the hypotenuse, which by now we know is the side opposite the right angle, is equal to the sum of the squares of the other two sides. I will explain it. You do not need to prove this theorem. You just need to know what it is and how to use it. While you do not need to prove this theorem, we will still investigate why it is true by looking at this right triangle here. Now remember, the theorem is the square of the hypotenuse is equal to the sum of the squares of the other two sides. We will use this as an example to show if that is true. So let's consider that triangle there. It's a right triangle. You have a right angle here. That is the hypotenuse over there, and these are the other two sides. So let's consider these two sides. We will use each side as a side of a square, and then we will divide the large square into smaller squares, each 1 square centimeter. So that is 1 square centimeter, and this here is 1 square centimeter, that area there, that there. So we have squared this side, we have squared this side. Count how many squares we have here. You will notice that we have 9 squares. 9 squares. Where did we get that from? 3 squared. So we have squared this side. And this side here, you will notice that we have 16 squares. Count them, 1, 2, 3, 4, and so on. Where did we get 16 from? 4 squared. So notice now, we have squared this side and we get 9 squared. We have squared this side and we get 16 squared. If we add them, how many do we get? 25. So the sum of the square of these two sides is 25. Remember, these two sides are not the hypotenuse. Now, let's do the same thing with the hypotenuse. Remember, the sum of the square of these two sides is 25. Let's square this one side. Do the same thing. We draw a large square here, divide each one in smaller squares, and we count how many squares we have here. You notice we have 25 squares. Where did we get that from? 5 squared. So remember Pythagoras Theorem. The square of the hypotenuse, which is that, is equal to the sum of the square of the other two sides. And we have found out that the sum of the square of the other two sides is 25. Now, this is not a mathematical proof of Pythagoras' theorem. It is much more complicated than that, since we would have to prove that this is true for all such triangles. And we haven't done that. We have just done that for this one right triangle, just to demonstrate that it is true in this case and to help you remember it longer and better and what it means. And while we haven't done the proof because it's not required by CSEC, we can accept it as true in all cases. CSEC, as I said, does not require you to prove this. All we did here was prove it in one case, but that doesn't mean that it will be true in every single case. Just in this one case. Just to help you remember it and to imprint on your memory this diagram here. The square of the hypotenuse is equal to the sum of the square of the other two sides. Add those two. So we now know what is Pythagoras' theorem. We have to use it to solve problems. We know what it is. Remind you again, it says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. So let's consider this right triangle. If this angle here is uppercase A, the right angle, then over here, which is the hypotenuse, is lowercase a. And the same thing applies for the other If that angle is uppercase B, opposite it is lowercase b. And if that angle is uppercase C, opposite it here is lowercase c. Now we could state Pythagoras theorem in an algebraic expression, which is a squared is equal to b squared plus c squared. Remember, the square of the hypotenuse is equal to the sum of the square of the other two sides. Now we have that formula. It has three variables, a, b, and c. If you know any two, it can be used to find the third. So consider this example here. If b is 8 centimeters and c is 10 centimeters, calculate a. So we know that a squared is equal to b squared plus c squared. We will remove that square from there by finding the square root on both sides. So we get a is equal to the square root of b squared plus c squared. We substitute the value for b and for c, and we get a is equal to the square root of 1/64, which is 12.8 centimeters. Actually, we have a little more significant figures than we need, but I don't want to confuse you right now with significant figures again. I just want you to learn this principle. So this is what you do. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. So remember, we are to use Pythagoras theorem to solve problems. And we know what is Pythagoras theorem. The square of the hypotenuse is equal to the sum of the squares of the other two sides in a right triangle, because you would only have hypotenuse in a right triangle. So let's look at another example. This time, we know C as 12 centimeters. We know A as 15 centimeters. We want to calculate B. We know that A squared is equal to B squared plus C squared. And you may see this differently because other teachers and books and so on may have different letters here. They may have C over here, and you may see C squared is equal to A squared plus B squared. It doesn't really matter. The square of the hypotenuse is equal to the sum of the square of the other two sides, whatever they are called. So we change that formula around, and then we remove this C squared from here. First, it becomes that, and now we will remove that square from there, square root of both sides, and we get B is equal to the square root of A squared minus C squared. We substitute the values we are given. We get B is equal to the square root of 81, and when you work that out, you will get 9, which is fine. Now you notice I have 9.0 because I am trying to maintain significant figures. I have two significant figures here. I have two significant figures here. So my answer should really have two significant figures. Now if you put 9, that would be acceptable. That is what you will actually see from your calculator. But if you think about it a little more, it should really be 9.0. Now, let's look at the converse of this Pythagoras theorem. Now, if the square of the longest side of a triangle is equal to the sum of the square of the other two sides, then the angle opposite the longest side is a right angle, so the triangle is a right triangle. So let's consider this triangle here. Notice there is no right angle anywhere. If we know the sides, and this is 12, this is 15, and that is 9, how can we show that this is a right triangle? How do we know that there's a right angle here? So we have to show that the square of the side is equal to the sum of the square of those other two sides. So 15 squared is equal to 12 squared plus 9 squared. Is it? Let's work it out. 225, that is 144 plus 81. And so on the left-hand side, you get 225 which is equal to 225 on the right-hand side. So this is a right triangle. Since the left-hand side is equal to the right-hand side, this is a right triangle, and so we know that this here is the hypotenuse, and over here is the right angle. Let's look at another situation with the converse. If the square of the longest side of a triangle is equal to the sum of the square of the other two sides, then the angle opposite the longest side is a right angle, and therefore that triangle is a right triangle. Now this time we are not given a diagram. The three sides of a triangle measure 7 centimeters, 9 centimeters, and 12 centimeters. Determine if this is a right triangle. Well, this is the longest side. So we need to see if the square of that longest side is equal to the sum of the square of those other two sides. If that is so, then we have a right triangle. If not, it is not a right triangle. So 12 squared is equal to 9 squared plus 7 squared. We have to find out if that is true. So this side is 144, that is 81 plus 49, and we get 144 is equal to 130. Well, not really. So since 144 is not equal to 130, this is not a right triangle. Another example, if the square of the longest side of a triangle is equal to the sum of the square of the other two sides, then the angle opposite the longest side is a right angle, and therefore the triangle is a right triangle. So the three sides of a triangle measure 6 centimeters, 8 centimeters, and 10 centimeters. Determine if this is a right triangle. So this is the longest side, so that would be the hypotenuse if it is a right triangle. So 10 squared is equal to the sum of the squared of the other two sides. 100 is equal to 64 plus 36 when you square those. So 100 on the left-hand side is equal to 100 on the right-hand side. That is so. Since the left-hand side is equal to the right-hand side, this is a right triangle. Now let's look at two actual examples. Well, let's look at two real-life examples. A swimmer swims directly across a flowing river that is 50 meters wide. Because of the action of the river current, she is swept 12 meters downstream from the opposite shore at which she started. How far did she swim? Okay, take your time. Don't get confused. First thing is to draw a sketch, a freehand sketch, just so you understand what the situation is. Once you understand the situation, you are more than 50% towards solving the question. So we draw a sketch. So this here is the river. That's the river bank. This is where she starts. I will call that point B. She intends to go over here to A. This river is 50 meters wide. She is swimming this way. The flow pushes her a little off track, so she actually swims this path and ends up at C. From here to here, we are told is 12 meters. This is a right angle. So if that is A, this is lowercase a. If this is B, that is lowercase b. And since that is C, this is lowercase c. So now we are back to Pythagoras Theorem. A squared is equal to B squared plus C squared. A is therefore equal to the square root of B squared plus C squared. And then when you substitute the numbers you are given, B we are told is 12, which is this 12 here. And C is the width of the river, which is 50 meters. You work through that. You get 144 plus 2,500. You square that. And you get 51.4 meters. That's the actual distance that she swam. Now you recognize that this has three significant figures. And the numbers we are dealing with, this one has one significant figure. This one has two. So your answer really should have one significant figure. So we need to round this off at this 5, which is the tens position. So she swam approximately 50 plus or minus 5 meters. Because you are rounding off at the tens position, your uncertainty is half of that position, not half of the number that is there. So half of 10 is 5. So this is our answer. Last question here. Remember, we have to use Pythagoras Theorem to solve problems. A plane took off from G, that's airport G, and flew 400 kilometers north to R. From R, it flew west to Q. If the direct distance from G to Q is 700 kilometers, how far is it from R to Q? Again, don't get flustered and don't think that this is confusing. First step, draw a sketch. Just to give you an idea of what information you are given and what you are asked to find. Just to remind you that these are the 4 points on a compass. If you stand with east on your right, then you are facing north. West is on your left and south is behind you. So that's just a reminder of the 4 main points on a compass. So we start out at G here and flew 400 kilometers north to R. 400 kilometers north, that is north to R. From R, the plane flew west to Q. This is west to Q. But you are not told how far is that. You are told if the direct distance from G to Q, from here to there, this distance here, is 700 kilometers. How far is it from R to Q? What is this distance here? That is what you have to find. Knowing that this is a right triangle, this is the hypotenuse, you can easily apply Pythagoras theorem to solve this problem. We already said this here is 90 degrees. Let's write it in. 90 degrees. So we have a right triangle here. This is the hypotenuse. If that is uppercase R, this here is lowercase r. And if that is uppercase Q, opposite it is lowercase q. And this here is G, opposite it is lowercase g. We want to find that distance there. So r squared, which is a hypotenuse, is equal to the sum of the square of the other two sides. So r squared is equal to g squared plus q squared. Remember I said this formula has 3 variables. If you know 2, you could find the third one, which is our situation here. So we change around that formula, and then we remove this q squared, and it becomes g squared is equal to r squared minus q squared. And now we get rid of that square by finding the square root of both sides. So g is equal to the square root of r squared minus q squared. We substitute the numbers we are given for r and q. You can enter all of that in your calculator and get an answer, but I will show you the steps. The square of that is this, and the square of that is this. Now we're going to subtract this from that, which gives us this. We still have to find the square root, which gives us 574 kilometers. Now, if you leave it like that, most likely CSEC will deduct a mark because you have too many significant figures. We have one significant figure here for the 700. We have one significant figure there for the 400. So your answer really should have no more than one significant figure. So you need to round off at that 5, the hundreds position. At 574, which 100 is it closest to? 500 or 600? It is closest to 600. So RQ is approximately 600, but since you are rounding off at the hundredths position, you take half of that position, not half of the 500, half of the position where that 500 is, which is the 100th position, and half of 100 is 50. So your answer is RQ. It's approximately 600 plus or minus 50 kilometers. So we were looking at this objective in section 12, use Pythagoras Theorem to solve problems. We have learned what Pythagoras Theorem is. The square of the hypotenuse is equal to the sum of the square of the other two sides. And we know that that must be in a right triangle because we are talking about hypotenuse. And you could only find hypotenuse in right triangles. So this is what we were just doing. Use Pythagoras Theorem to solve problems. That brings us to the end of video 21 based on objective 12 in section 8.